This is MathGuide.com. My name is Mark Karadimos. Today we're going to solve trigonometric equations. And in this video we're going to show two examples, and the problems here are not going to require any factoring. Okay, let's get started. Here is example number 1. For our first example, we're going to be dealing with a problem that has cosine in it. And also we're going to see some fractions. Alright, so here's our problem. So if this was an algebra problem, we'd be solving for cosine of x. And in this case, we need to get rid of this addition of 3 halves, so the opposite. Subtract 3 halves. So we're getting 2 cosine of x is equal to, let's see, 5 halves, take away 3 halves is 2 halves. And 2 halves is 1. Divide both sides by 2. So we're getting cosine of x is equal to 1/2. Alright, now at this point, once we have our trigonometric function all alone, what we are going to do is try to figure out where to draw our reference triangles to get the answers. So first of all, we need to determine where it is to draw the reference triangles, and we use this handy dandy little diagram. All seniors take calculus. What this stands for, of course, is all trig functions here are positive. Sine is positive in quadrant 2, tangent's positive in quadrant 3, cosine's positive in quadrant 4. So this tells you where all trig functions are positive. Alright, now being that this is the case, we're also going to see that, hey, we've got a positive 1/2, so, and it's cosine, so we're going to be using quadrants 1 and 4. So now what I do is draw a reference triangle in each of those quadrants. What does that mean? It means I draw a y-axis and an x-axis, and now I draw 2 right triangles, one in quadrant 1 and the other in quadrant 4. Okay, so I've got these 2 little right angles over here, and I'm now trying to figure out what this reference angle is, as is this one. So let's see, what's the definition of cosine? We know from SOHCAHTOA, that it's adjacent over hypotenuse. So here's our angle, and the adjacent side is 1, the hypotenuse is 2. Adjacent side is 1, hypotenuse is 2. And you should recognize that we have a missing side, and the missing side is radical 3. Over here, of course, it would be negative radical 3 because we're below the y-axis. Alright, still, since it's a 30, 60, 90 triangle, if you recognize those sides, and you should have 45, 45, 90, 30, 60, 90 relationships memorized for trigonometry. So we need to figure out what is the angle opposite the square root of 3. And if you know anything about your triangle, you know that it is a 60-degree reference angle. So that means this is a 60-degree reference angle also. Alright, with that in mind, we now, of course, when we measure our trig angles, we always start in the east and we revolve counterclockwise. So I want to know what is this angle right here in the first quadrant. I want to know what the angle here is in the fourth quadrant, so you revolve around to get to that angle. So the first angle, if you were to measure it starting from the east and rotating counterclockwise, that would be 60 degrees. If you go around all the way here in the fourth quadrant, we know it's the fourth quadrant's got to be between 270 and 360. Well, it's something plus 60 is 360, or all the way around the circle. So it's got to be 300 plus our reference angle is 360. So in other words, our angle it's got to be 300. And there you go. We've got our 2 answers to this trigonometric equation. Here's example number 2. For this example, we're going to see a problem that has a trigonometric function that's squared. It's common to see that. It's just like it's common to see an algebra problem that has a square in it. And if this was an algebra problem, we would get the variable alone. Well, in this case, we're going to try to get our trigonometric function sine of x alone. Okay, so what are we going to do? We're going to add 1 to both sides. That's the opposite of subtracting 1. So we get 4 sine squared x is equal to 3. Okay, I'm going to divide by 4 to get rid of that multiplication by 4. So let's see, I get sine squared of x is equal to 3/4. Alright, so let's see, the opposite of squaring is square rooting. And when we take the square root of both sides, we're going to do plus or minus. Okay, do plus or minus. Alright, so let's see. When we take the square root of sine squared, we get sine. So the square cancels the square root. And over here, we could take the square root of the top and bottom of the numerator and denominator at the same time or separately. So I'm going to do them separately. So the square root of 3 is radical 3. We take the square root of 4, 2. Now normally, of course, you take your little handy-dandy guide that says all seniors take calculus. And it tells you where all the trig functions are positive. And so we know that all trig functions are positive in the first quadrant, sine is positive second, tangent's positive in the third, cosine's positive in the fourth. Well, for this particular problem, I'm not only dealing with positives, I'm also dealing with negatives. So sine is positive up here in the first two quadrants. That means it must be negative down here in the second two quadrants. So I'm going to use the first two quadrants for positive radical 3 over 2, and then the last two quadrants for negative square root of 3 over 2. Okay, let's draw the picture. So first of all, I'm going to draw my y-axis, then I'm going to draw my x-axis, and I'm going to put reference triangles in every quadrant. Okay, so there you go. I got that guy. So now I move on. I go, let's see, draw another one there and another one there. Okay, it's a little lopsided, but it's okay. This is just a guide. They should all be congruent, but it's just a guide to figure out what your reference triangles are and to find specifically what the reference angles are. So I'm trying to find all of these little angles. And they're all going to be equal for this problem because the ratios are all going to be the same, relatively speaking. And let's say we deal with the first quadrant, and we know the definition of sine, SOHCAHTOA, is opposite over hypotenuse. So of course this tells me where to place these values. It tells me that for this angle I put the opposite side as radical 3, and I put the hypotenuse as 2. Likewise, I'm going to say the opposite side is radical 3, hypotenuse is 2, and I'm going to do that all the way around. Okay, now this isn't exactly perfect because this over here is above the x-axis, so they got square root of 3. This is above that square root of 3. But down here it's negative because I'm below the x-axis. Likewise over here, negative. So you can see I've got negatives in these two quadrants and positives over here. I'm covering my bases here because I've got positives and negative ratios. Now of course this missing side over here is 1. This missing side over here is negative 1 because it's a 30, 60, 90 triangle. Maybe you recognize that it's a 30, 60, 90 triangle. And if it is a 30, 60, 90 triangle, then I know the side opposite the radical 3 is 60 degrees. So that means all of these reference angles are all 60 degrees. Fantastic. So again, when you're trying to find the trig angle, we use these reference angles as a guide. So remember, we rotate around starting from the east, and you rotate counterclockwise. Again, I'm going to rotate counterclockwise to get here. I'm going to rotate counterclockwise to get here. And I'm going to last for the fourth quadrant. I'm going to rotate all the way around to get over here to the last quadrant. Okay, so let's find those angles. Well, the first angle is going to be in the first quadrant. It's going to be between 0 and 90. And I'm going up 60 degrees. It's 60 degrees. Okay, let's get to quadrant 2. So I rotate over here, and that's going to be, let's see, something plus 60 is going to be 180 degrees, so it's got to be 120 plus 60. So it's got to be 120 degrees is the yellow angle. In the third quadrant, I have to rotate to 180 degrees and then 60 degrees more. So 180 plus 60 is 240. And for our last problem, we're going to rotate around something plus 60 is 360, right? Something's got to be 300, right? 300 plus 60 would be all the way around the circle. So it's got to be a 300-degree angle over there. And we have our answers. You know, there are an infinite number of solutions to this problem. You know, if you keep on adding 360 on 60, keep on adding 360 on 120, and so on, you're going to find an infinite number of solutions. So these solutions only indicate answers in the interval between 0 and 360. And usually when you're doing these problems, you only want the solutions for the first revolution around the circle. So just like for the first example, I only found the answers between 0 and 360 because that's usually the standard, or 0 between 2 pi if you're in radians. All right, make sure you go back to mathguide.com, check out our interactive quizzes, instructional videos, and text-based lessons. Take care.